Hello, I'm Mrs. J, and today we're going to talk about scatter plots and regression lines. A scatter plot is when you're taking different data, the x and the y values, and you're plotting them on a graph. So you're comparing two items and see if they have a relationship among each other. If you look at this first one, notice the data is close to the line. It has a linear relationship with that line, and you can use that line to find values. So it's a strong positive relationship. The reason it's positive is because as you're increasing, if you're moving from left to right, the line is increasing. This one is also increasing, so it's a positive relationship, but notice the data spread all over. Now this one is everywhere. This has no correlation. And then the next two are decreasing. One is stronger because the dots are all near the line, and one is weaker because they're spread out. Another thing we can look at is called R squared. It tells you how strong the relationship is. And the closer R squared is to 1, the stronger or closer these dots are to the line. So these two strong ones, the R squared would probably be somewhere between 0.8 and 0.9. Where these two would be closer or below 0.5. The more spread out it is, the closer it is to 0. And this one would be, R squared would be 0 because it's spread all over. To get an R squared of 1, all your dots will be on the line. So if all these dots were on the line, then R squared would be 1. So the closer you get to 1, the stronger the relationship. The closer to 0, the weaker the relationship. Well, then when you see an R squared, how do you know if it's strong or weak? Your book says 0.5. So anything above 0.5 you could consider strong. And anything below 0.5 you would consider weak. Okay, let's look at a couple examples. Oops. Okay, I made a small example. I want to show you one where the relationship is all on the line. So if we highlight it to graph a scatter plot, you click Insert and go over to Scatter Plot. And there it is. To get the line, okay, it doesn't want to come up. You should get, there it is. This plus sign, so I just moved it around and it finally popped up. Now if yours won't come up, then it'll be up here, Add Chart Elements. But when I click on it, I want to add axes. If you want to add, these really don't have much to them, but X and Y. But what we want is the trend line. See that line that it made? All the points are on it. Now we can get some more information under More Options, and then you go to the bottom. You want to display equation and display R squared here at the bottom. Click both of them. And then notice the equation popped up. I'm going to make the letters a little bigger. Excuse me. So you can see them a little better. Okay. Notice R squared is 1 because all the points are on the line. And then our slope is -2. What that means is each x value, as it increases by 1, the y value increases or decreases, in this case, by 2. 14, that's your y-intercept. Notice if this keeps going, it would hit at 14. But the slope is decreasing. It would be a strong negative relationship. So when R squared is 1, the points are all on the line. Now what happens if we change these? If I go in here and change them, watch how the graph and the equation in R squared change. So I changed my numbers. Here, I'll put what the other numbers were next to it. So I had these, I switched to these. Notice then the data is spread all over in my line. And R squared, I think we have to redo R squared to get it. Doesn't want to delete. Okay, there it goes. There we go. Notice now the R squared is very small, close to 0, because my data spread all over the place. So the closer it is to 0, the more spread out it is, and when it's all on the line, it will be 1. Let's do a story problem. Now this one was, the temperature was taken, and then they listened to how many chirps a cricket makes in a second. And so the idea was, the warmer it is, our crickets chirping more than when it's colder. And so they took a sample of 15. They took the temperature and the number of chirps per second. And let's see if there's a relationship. So if we highlight it, let's highlight. If you highlight the words, it'll put the Y in the title. And there. You can tell looks like there'll be a strong relationship because it's together, and it'll be a positive relationship because it's going up. So we can click here, we can get our titles, trend line, go down to more because we want to get our equations. Did it pop? It doesn't look like it popped up. Let's try again. There we go. So you click the bottom two, that's what gets you the equations. And then if you want to make them bigger, you can highlight them and then just change your size. There we go. And you can see the line in there. You can also make it darker, lighter. So my R squared is 0.69, which means it's a pretty strong relationship. So 0.6923 in my trend line, Y equals 0.203, X plus 0.4593. Okay. So all I did was highlight the data, insert, and scatter plot, and we got all this. Now you can name your titles. Let's see. Temperature. And number of chirps. And if we want to add to the to this, we could put depending on temp. I don't like the way they did that. Just leave it that way. You can kind of see the line a little bit better with that one. I like the solid one. There we go. Okay, now what does that line mean? Well, let me go over here. Blue. Okay. There we go. So the R squared told us it was a strong relationship. Between temp and number of chirps. We also know it was a positive relationship because it was going up. And that's your slope is positive, so it's going up. The y-intercept, or y equals mx plus b. The y-intercept is the b. So in this case, it's 0.4593. So that means when there's no temp, there is about a half a chirp, because that's approximately 0.5, which is a half chirp per second. So sometimes y-intercept does not necessarily make sense because we don't have no temperature. There's always a temperature. If you wanted to think of it as 0 degrees Fahrenheit, but actually y-intercept means no, none. But you could do at 0 degrees Fahrenheit, there's a half a chirp per second. Or 1 chirp every 2 seconds. Slope. Now, the slope, the m, it's the one attached to the variable, in this case x. So it's this. This is your slope. The slope is your change in y over change in x. And in this case, x is our temperature, and y is the number of chirps per second. So if we leave this in decimal form, as temperature increases by 1, because it's over 1 degree Fahrenheit, the number of chirps per second increases by 0.2. Now another way you could write that if you don't want 0.2 chirps, we know the slope is 0.2, which is 0.2, which reduces to 1/5. So then we can use this. When the temperature goes up 5 degrees, the number of chirps goes up 1. So as the temperature increases by 5 degrees Fahrenheit, the number of chirps per second increases by 1. So if the decimal isn't as easy to understand, you rewrite it as a fraction, 2/10, and reduce it. And then, so every 5 degrees the temperature goes up, there's an additional chirp per second. That's everything for Chapter 8.